Hello, my name is Shivdat, and today we're going to be looking at a computer science problem. It really is a hackneyed problem. It's been used in interviews for a long time, in a huge number of interviews, and so you may very well have seen this before. But if you haven't, now would be a great time to see it because you really should know it. It's a very commonly seen idea, but it's a nice, neat trick. It really doesn't involve much computer science knowledge. It's algorithmic, and it's more like a brain teaser, although it's applied in a computer science setting. So the problem is this. You have an integer array of size n minus 1. And it contains all the integers from 1 to n, except for one missing integer. So it could look something like this, maybe 2, 33, n. This is going to be the maximum. It's going to be 62, 1. This is going to be the minimum element. It contains, remember, integers from 1 to n, except for 1. 7. So this array is full, it's size n minus 1, but from 1 to n, one number is missing. And the question is to find the missing number using the most efficient algorithm as possible. So if you have seen this before and you're smiling away, no need to watch the rest of the video. If you haven't, now would be a great time to pause the video and think about it. Alright, so what are some ways to think about this problem? I know when I see problems like this, the first thing that comes to my mind is sorting. Sorting is just so useful, it's just so applicable in so many contexts, and it makes the problem so much simpler that I usually sort. So if I was to see this problem, you know, if it was randomly thrown to me and I didn't know whether it was an easy problem or a hard problem and I had never seen it before, the first thing I would do probably is say sort the array. I would sort it from, so it would be 1 to 30, 1, 2, 3, 7, 33, 62, n. And I would say keep incrementing, start from the beginning, and keep incrementing till you don't see, till the next value is not 1 plus the previous value. And the first value should be 1. Check that condition. If that holds, then every consecutive value should be 1 plus that previous value. And the first place at which that condition breaks is the missing number. N plus 1 would be the next number, would be the missing number in that case. That's fine, except that sorting takes n log n time, right? For an integer array of size n, here's n minus 1, but the order would still be n log n. And the idea is we really want something more efficient. So can you think of something linear, or maybe even something better than linear, constant time? Really? Can we have an algorithm that does this in constant time perhaps? Or definitely better than n log n. N log n is no good. So pause the video, think about it. Alright, so we use a very, it's not too hard to come up with this, but it's not too easy as well. But once you've seen it, you'll never forget it. The idea is to use the sum of the elements in an array. And we know that the first n natural numbers, in other words, the sum of the numbers from 1 to n, natural numbers from 1 to n, is equal to n into n plus 1 divided by 2. Now how do we know that? Well, this is an easily provable result. I'll show you how to derive it in a second. But there's a very interesting story associated with this. Gauss, the famous German mathematician, when he was in, was he 5 years old? I forget, 5 years old, 10 years old, and somewhere in that range. His teacher, to keep the students busy, told the students to sum up the first 100 natural numbers, numbers 1 plus 2 plus 3. The teacher thought that would keep the students busy, the teacher would do his work. Little did the teacher realize that, barely a few minutes later, Gauss was there in front of him with the solution. So Gauss's idea was as follows. He did it for the case 100, but you can do it for the case n. The sum we're looking for, let me use s for sum. So s is equal to 1 plus 2 plus 3 plus n minus 1 plus n, right? That's what the sum is. But what if I write the same sum, but in the reverse order? N plus n minus 1 plus n minus 2 plus 2 plus 1, right? So it's like I'm writing the same sum except backwards. And now I just sum these two rows. So what I get is s plus s, or 2s, is equal to n plus 1 plus n plus 1. I just keep summing the corresponding terms. Plus n plus 1. Because notice, this number is becoming more negative by 1, this number is becoming more positive by 1. So it's always going to be a plus 1 difference. Plus n plus 1 plus n plus 1, this last case. And notice that we're adding n plus 1 n times. So 2s, so s is equal to n times n plus 1, and we're taking the 2 onto this side, divided by 2, which is nothing but this result. So that's the derivation, that's how we derive this result that we got here. So it's very simple. This calculating, you know n, what the number n is, that's given in the problem. Calculating the sum would take constant time, right? And all you have to do is calculate the sum of the elements in the array and subtract that from the sum, what the sum should be, to find the missing element, right? Because if that element was there, you would get this sum. So the sum you get plus that element that should be there would equal to this sum. So if you subtract it through, the difference would be the missing element. That's it. And adding these would take linear time. So it's not really there's no constant time algorithm for this. But you can definitely do better than n log n, better than sorting, by just summing the elements of the array, keep going on and on and on, and then subtracting, calculating this value, find the difference between the two. That's the missing element. Easy, wasn't it?